Okay, 2.2. I think this is a relatively easy bunch of questions. Yeah, for sure, at some point, you guys, you're going to have to graph a polynomial function. But I'm not sure I'm going to pull that from this section. I feel like maybe a future section will have a better polynomial type for you to graph. I don't know. We'll see. We'll see. But for sure, you're going to have to graph a polynomial. And you should know about end behavior. To me, that's a giveaway question. Those are pretty easy. Intermediate value question. This is another giveaway question to me. So those are ones I might include just to give you some easy points. But that means you should also know what those are talking about. Okay, number 4. Describe the end behavior of the given polynomial. You know, don't necessarily trust what I'm saying because I haven't written the test yet. So I'm kind of going on. I kind of might not do exactly what I'm talking about here. Okay, just ignore one thing. Okay, let's do number 4. Describe the end behavior of the graph. End behavior is determined only by the leading term. Yeah. So what's the end behavior? As x goes to negative infinity, what happens to x to the 4th? It goes to positive infinity. Yeah. As x approaches positive infinity, x to the 4th, what happens? Well, it's to the 4th, it's positive, it goes to positive infinity. Yeah. So it's positive, it's always positive, right? Because it's to the 4th power. So that was number 4 already. Easy, yeah? Easy couple points there. Okay, number 5. Find the, for the following polynomial function, that thing, describe the end behavior, find the zeros, which are easy. Okay, let's just do the steps one by one. Let's get rid of this so I have more space, actually. So 5. Okay, part A, end behavior. So again, similar things to the previous question, except this time it's actually harder to see off the bat. So what you have to do with something like this is first figure out what is the real meat. If I was to expand this whole thing, what would the leading coefficient be? So I'm going to take this 2. I'm going to take the x. I'm going to take this x to the 4th, and the x. That'll be 2 times x, x to the 4th, and x. Because that's what's going to end up popping out if I was to expand this whole thing, right? And that would be 2x to the 4, 5, 6 to the 6th power. Okay. I should have chosen maybe slightly different values here because that's not so exciting. It's another even power. It is what it is. What I mean by that is, look, what happens? It's the same thing as the previous question, right? As x goes to negative infinity, we're basically going to act like 2x to the 6th. And that's going to go to positive infinity. And same thing as x goes to positive infinity. Yeah? F of x is going to approach positive infinity. It's going to continue growing. But that is important information for us to know when we try to graph something. We want to know it's going to go up toward the end and as I go to the left. Okay, part B, find the real zeros. Determine whether it crosses or touches. It's easy because it's already factored for us. So zeros at -1, +2, and -3. Yeah, just from these 3 factors. Okay, now the first one and the last one, these ones, it just crosses because those have odd power, just a single power. The middle one has an even power of 4. So this one, it touches. It just touches, kisses. And it returns back, yeah? Okay, determine where this above and below the axis. Okay, so here's where we do something similar to what we did. Oh, no, I'm sorry. I'm thinking I recorded these videos in a weird order, so we haven't done this yet. Okay, what are my zeros? My zeros are -3, -1. I'm organizing them in increasing order, yeah? +2. So to check whether I'm above or below, let's just check test points. I'm going to do to the left of that. In between would be -2. In between -1 and +2 would be 0. And after +2 would be 3. So those are going to be my test points. Okay, I'm testing with this function here, yeah? So let's check -4 first. So kind of zoom in here for a second with me. I can't because I need to see that. I need to see this stuff here. So let's look. What I'm looking at here is I'm looking at this function expression, yeah? I'm thinking, okay, from -4, what happens? From -4, -4 plus 1 is going to be negative. -4 minus 2, but then eventually to the 4th power, it's always going to be positive because it has that 4th power. Negative 4 plus 3 is going to be negative. So I got two negatives and a positive. That makes this overall positive here. Okay, what about if I plug in negative 2? What happens? If I plug in negative 2 plus 1 is negative. This guy's always positive. Negative 2 plus 3 is positive. So overall, that's negative. What if I plug in 0? This is going to be positive. This is always positive. Positive. 0 plus 3 is positive. So overall, this is going to be positive. Okay, now what if I plug in 3? I got 3 plus 1 positive. This is always positive. 3 plus 3 positive. So overall, positive. Okay, that's where above and below. As I'm doing this, I'm just realizing also I didn't even have to do that actually. And the reason is because I could have just used what I know about multiplicity of roots, right? Or earlier we said I knew what happens if it's crosses or touches. So I actually didn't have to do that chart. I could have just gone like this. Watch. So I've got negative 3 as a root, negative 1 is a root, positive 2 is a root, right? And I know my end behavior, it's going to go up to the left. It's going to go up to the right. So I can start from either side, up to the left. First one crosses through at negative 3, right? Hits positive, negative 1, sorry. And it also crosses there. So crosses, and then this one is just a touch, because that one we said is a touch. It's a multiplicity of 4. And then end behavior matches what I said, right? As I go to the left, it's going up. As I go to the right, it's going up. So those are both good. And then let's just check. Is it matching what I said earlier over here? Yeah, positive here, yes. Negative, and then positive, and then positive, yes. So everything matches up. Now, did I answer the question? Where is the graph above and below? Well, this table kind of says it. I didn't explicitly write it, but yeah, we know, right? And we also graphed it, just showing where it's above and below. Okay, what's the y-intercept? Okay, that's when x is equal to 0, right? So x equal to 0, plug that into this thing. It's going to be 2 times 0 plus 1 is 1. 0 minus 2. Negative 2 to the 4th power, 2, 4, 8, 16. It's going to be 16. And then 0 plus 3 is 3. So I've got 2 times 3 times 16. 2 times 3 times 16 is 96. So y-intercept is 0, comma 96. So this is a lot higher than it looks. That's 96 over there. Okay. Symmetries. Symmetries, no symmetries. You can check by plugging in negative x and notice that it doesn't equal, and it's also not the opposite of the original. Determine maximum number of turning points. I guess I should write that down. Yeah, I guess I should be labeling these things. So we determine above and below here. The y-intercept was over here. Part E, no symmetries. I can also just tell by looking at my graph that I already did. Part F, maximum turning points is a result of the total degree. Degree it's a 6th degree, as we saw earlier, right? Taking all the leading terms and multiplying them out. So that means at most 1 less, at most 5. 5 turning points. And then G, we already actually sketched the graph. So there it is. Okay, that's question number 5. Okay, good news is I was starting to get tired of working through these questions. Like I said, I did the videos out of order, so I've actually done a lot of these. I think after this one I should take a break so I don't lose my energy as I'm talking to you. But yeah, good news is that the last question here in this section is an IVT question, intermediate value question, and those are really fast and easy. At least the way I have it. I'm not asking you to approximate it to any decimal place. I'm just asking you to show that it exists, to show that a 0 exists. So basically just understand what it says, yeah. So how do I know? Here's the interval. I'm checking from 2 to 3, right? That's the interval. And I want to know that there's a 0. Well, if there's a 0, if there's going to be a 0 between 2 and 3, then one of these guys should be positive, one of them should be negative, or vice versa, right? So what is f of 2? That's 2 to the 5th minus 9 times 2 to the 2nd minus 15. Okay, 2 to the 5th is 2, 4, 8, 16, 32. Minus 9 times 2 to the 2nd is 4. Minus 15. And 32 minus 9 times 4 is 36. And then minus 15 is going to be negative 19. But important thing here is that it's negative. Okay, now I'm going to check f of 2. I'm sorry, f of 3, I mean. That's 3 to the 5th. Oops, sorry guys. This is negative 19, importantly. I missed the most important part. Yes, this is 3 to the 5th minus 9 times 3 squared minus 15. Now 3 to the 5th, that is 243. 9 times 9 is 81. And minus 15. And importantly, that's going to be positive. I can see already without actually finding the answer. But let's find it. Okay, it's 147. Okay, so one is positive, one is negative, and that's all you have to show. And just now at the end, you just write this same kind of routine sentence. Think about what it means as you write though. Say by the IVT or intermediate value theorem. Let's not be lazy and write it out. Intermediate value theorem. So you're invoking this theorem to say that there must be a 0. There must be a 0 because at one end of the interval you're negative, one interval you're positive. So that means there must be a 0 in between. There exists a 0 between negative 9. Oh, I'm sorry. Not negative 19. Between 2 and 3. Let's be more specific. Between x equal to 2 and x equal to 3. Or, you could also say, instead of this sentence, you could have said in the interval that they gave you from 2 to 3. I don't know why it keeps doing that. Okay, there you go, guys. That's it. 6. Easy question.